Okay, we're going to look at number 1 in section 3.2. I've pulled it up on the screen here for you. It is going to be basically clicking or dragging these descriptions into the 5 different boxes labeling or describing the graph of the function at these points A, B, C, D, and E. So just a couple things about the function. You see the function is actually defined for all values except at point D, which looks to be about x equal 8, because there's no point anywhere there. There's a hole in the graph there. At point C, which is about maybe 3, there's a hole here, but there's a point down here. So the value of the function at C or at 3 would be about negative 4 point something. So when I'm looking at these descriptions, one is the function is continuous and differentiable at the point. So remember what continuity means. Continuity means the value of the function exists, the limit exists, and those values are equal to each other. Okay, so there's no holes, no gaps, no jump discontinuity, no vertical asymptotes, that sort of thing. So you can really think about the first two descriptions. The function is continuous. In this one, it is also differentiable, and here it's not differentiable. So what's differentiable mean? Simply means the derivative exists. And graphically, if you recall, a derivative will not exist if the function is not continuous. Okay, so obviously notice down here the limit at the point exists, but the function is not continuous. We obviously can't talk about it being differentiable in that point. But if it is continuous, it can still not be differentiable if there's a sharp turning point or if there's a vertical tangent line. Those are the two main conditions we will be looking at in these graphs. So let's go through it. I'm actually going to start with the bottom. Where do we have the function not continuous? Because the first two, they're continuous. Well, clearly we just said at D, there's no value for the function. The function does not even exist at D. There's no output. So the limit though does exist as we get close to x equal 8. It looks like, right, we're going right to the y coordinates of this hole. So the limit as x approaches 8 appears to be pretty close to 6. It looks like we're at a height about 6, maybe a little bit more. But so D, the limit of the point exists, but the function is not continuous because it's not even defined at that point. So remember, the limit has nothing to do with the value of the function at that point. So if I were to fill in this hole at D, the function would then be continuous, but the limit would still exist. Okay. And where else are we not continuous? Well, again, we've got a hole in the graph here at the x equal 3. So this point here, there is a value of the function, right? Again, the function is the function f of 3 is about, again, negative 4 point something. So the function exists. The limit also exists. The limit, though, is equal to what? As we get close to x from is close to 3 rather, from the negative and the positive side, we're getting closer and closer to the y coordinate of that point, which is about 2. So the limit at 3 appears to be 2, but the value of the function is about negative 4 point something, maybe negative 5. So those values not being equal means the function is not continuous, even though the limit exists. Okay. At the other points, we are continuous. The limit exists and the point exists, and those are all equal. But you'll notice at points B and E, we have sharp turning points, right? Where the slope is changing. Notice on this side of B, below, B is about at negative 3, it looks like. So for values less than negative 3, notice the slope is positive. The slope is positive at any point on the graph. Whereas for values greater than negative 3, at any point, the slope is negative. In fact, this being like a linear function, the derivative would just be equal to the slope of this line. And so there's a drastic change at B, and because of that, it is not differentiable at that point. But it is continuous. The value of the function at negative 3 is about 14, and the limit as x approaches negative 3 is 14. So the limit exists, the value exists, and those are equal. So it is continuous. There's no hole, no gap, no jump or anything at B. Similarly at E, we have the same thing. It is continuous, but we have a sharp change, a cusp or a sharp turning point there. So again, it is not differentiable at that point. So only at A is it differentiable. Notice the transition here is smooth. There's no abrupt change. And in fact, right at A, it looks like the horizontal, we would have a horizontal tangent line, meaning the derivative would be 0, the slope of that horizontal line being 0. So the function is continuous and differentiable at that point. Okay, so that's sort of the analysis of this. Hopefully this makes sense. Make sure that you're understanding this. If not, please let me know.